All right, this is number 16 on page 427. We're going to do this problem using the p-value method. And it says, the Old Farmer's Almanac stated that the average consumption of water per person per day was 123 gallons. To test the hypothesis that this figure may no longer be true, a researcher randomly selected 16 people, found that they used on average 119 gallons per day, with S, which is your sample standard deviation, of 5.3 gallons. At alpha equal 0.05, is there enough evidence to say that the Old Farmer's Almanac figure might no longer be correct? All right. So the Old Farmer's Almanac says that we use 123 gallons per person per day. Think about that. Think about when you use water all day. Take a bath, take a shower, cooking, drinking. 123 gallons, that's a lot of water per day, it's saying. Flush the stool, don't forget, there's a lot of times you might not think about using water, but you are. So let's go ahead and start by writing out our step A, our first step in the p-value method, or the traditional method, is always to write the null hypothesis and the alternative hypothesis. And the Old Farmer's Almanac is saying that the mean is equal to 123 gallons of water per person per day. So the alternative would be that it's not equal to 123 gallons per person per day. Now we have to figure out the claim. The claim's a little tricky here. We're not real clear on what the claim is, I don't think. But at the very end of the problem is normally where you figure out what the claim is. Is there enough evidence to say that the Old Farmer's Almanac figure might no longer be correct? So they're saying maybe it's not correct. So I'm going to say that the claim is that it's not equal, the mean is not 123 gallons per person per day. I'm going to put the claim down here. If they're kind of questioning the correctness, we usually put the claim with the alternative. N is 16 in this problem, so degrees of freedom would be n minus 1 or 15. They give you a sample mean of those 16 people was 119 gallons. Sample standard deviation, 5.3 gallons. Give us an alpha value of 0.05. All right, when you're doing the p-value method, you don't have to find critical values like you do with the traditional method. You skip right to step B, which is to find the test value. Now, the test value could be a z or it could be a t when you're testing means. In this case, if we knew the population standard deviation, we'd automatically use our z formula, but we don't. We only know the sample standard deviation. If n is greater than or equal to 30, we'd use z, but it's not. It's less than 30. So we have to use t here. So our t formula is going to be x bar, which is 119, minus mu, which is 123, divided by the standard error of mean, which is 5.3 divided by the square root of n. Your standard deviation, 5.3 divided by the square root of 16, which of course would just be 4. You type that in your calculator. You're going to type it in all at once. You put parentheses here, and here, and here, or of course you could just do the square root of 16, which is just be 4.
It's negative 3.019.
Okay, thank you. Negative 3.019. One.
Negative 3.02.
Okay. Yeah. And yeah, it would round to 2. Yes. 0.19 round to 2. Yeah. So there's your t-score. Now, your third step in the p-value method is always to find the p-value. So go to your t-chart for that. You're going to go to your t-chart. You're going to go down to degrees of freedom on the left side of 15. You're going to look across, and you're trying to find the number negative 3.02. And as you look across here, and I guess we should talk about, is this two-tailed or one-tailed? It's two-tailed because of the equal sign, right? We don't know if we're trying to figure out if we're looking at the right tail or the left tail, since it's two-tailed. So we're going to look. We're still going to look for that number, negative 3.02. And we're going to look up here at two-tailed. And you see numbers like this, 0.691. Well, that's not anywhere close to negative 3.02. And actually, we'll be looking for positive 3.02. There's no negatives in the chart, so just ignore the negative when you're looking it up on the T-chart. Then you find 1.341, and then 1.753, and then 2.131. We're getting closer to 3.02. And then 2.602, 2.947, and that's it. So is 3.02 between any of these? No. Okay, and look at our alpha values. Our alpha values are getting smaller up here. Our alpha values are 0.5, 0.2, 0.1, 0.05, 0.02, 0.01. So, for example, if our t-score would have fallen between these two numbers, then we would have set our p-values between these two numbers. Or if, for example, our t-score would have fallen, if this would have been like positive 1.5 or even negative 1.5, ignore the sign when you look it up, then we would have set our p-values between 0.1 and 0.2. But in this case, our number, 3.02, ignore the negative, is bigger than this. So what would I say up here? P-value is what?
Greater than 0.01.
Now these numbers are getting
Oh,
smaller, right? So our p-value would be out here somewhere. Our test value is out here somewhere.
less.
Yeah, so it'd be less than, because the numbers are getting smaller. So for part C, we're gonna say our p-value is less than 0.01. We don't know exactly what it is, but we know it's less than 0.01. And we could use a calculator to figure it out exactly, but we're not going to. We don't really need to know. Step D, we have to decide to reject or not reject the claim. Well, my alpha, which I erased, what was alpha here? 0.05?
Yeah.
Okay, so alpha, let's look at a number line here. Here's 0, 0.01, 0.02, 0.03, 0.04, 0.05. My p-value is something less than 0.01. So my p-value is something down here. Can't be negative because p-value is an area. So it's somewhere in here. My alpha is up here at 0.05.
Do we have to draw that?
No, you don't have to draw that. I'm just drawing that to help you picture it. So is the p-value smaller than alpha? Yes. So that means you should reject, anytime the p-value is smaller than your alpha, you should say reject the null. And what this is telling me, p-value being less than 0.01, is saying that if the true amount that people actually use is 123 gallons per person per day, then we would get a sample mean of 119 gallons less than 1% of the time. Okay? So if this is really true, it's very unlikely, less than 1% chance, that you would get a test value of 119. All right? So very unlikely that 119 would just happen by chance. So what we're saying is that we're probably getting the 119 because this is not true. So we're rejecting it. So for D, we're rejecting that's 123 gallons. So for part E, if the claim is in the top line, then we say there is enough evidence to reject or not reject the null. But if the claim is down here, we don't use the word reject. What word do we use? Support. So if we're rejecting the null, that means we think it's false. Not proving it, but we think. So we think the alternative is true. So we'd say there is enough evidence to what? Support the claim. Yep. So step E, there is enough evidence to support the claim. And then after the word claim, you say that we do not use 123 gallons per person per day. And according to this evidence, it looks like we use less, because the sample mean is less than 123. Any questions about that? Might not seem like a big issue, but I know I went to